So factoring study guide, page 2. I'm not going to work out all of these on the study guide video. They're mostly the same thing over again, just with different numbers. So I'm just going to work out about, of these 6, I'm going to work out about 2 of them. Most of the stuff from the first page applies to here for factoring. So I'm going to start with this right hand one here, the right hand side one. So it wants us to factor and then find the x-intercepts of the parabola. Okay, so first thing we got to do, so we still got to factor. So a lot of the skills from the first page are going to apply here. So first thing we do, we have a 5, we have an 18, we have a 9. We check to see if they have a common term. They don't. So we go straight to multiplying a times c, because we want to factor this out first. So 9 times 5 is going to give us 45. So I'm going to rewrite this as x squared plus 18x plus 45. And now we're looking for, I'm going to use a lot of room here, 2 numbers that multiply up to 45 and add to 18. And the 2 numbers that we'll be looking for is 15 times 3. So we're going to rewrite this as x plus 15 times x plus 3. And then we have to, again, do that undoing that multiplication by 5. So we're going to divide by 5. Divide by 5, divide by 5. I'm looking at 15 over 5, that fraction there. 5 goes into 15 3 times, so it goes in evenly. So this is going to be x plus 3. And looking at the other factor, 3/5, 5 doesn't go into 3 even amount of times. I guess this is a decimal. We can't reduce it, so we shoot it out in front. So 5x plus 3. So now what we do, remember, we take those 2 and we set them equal to 0. So we have x plus 3 equals 0. And then we have 5x plus 3 equals 0. So this gives us our 2 x-intercepts. So the first one, it's pretty simple. Subtract 3 on both sides. And we get that x equals a negative 3. So that's our first x-intercept here for this one. So 5x plus 3, we also got to get that x-intercept there. So we have to subtract 3. Subtract 3. We have 5x equals negative 3. Divide by 5. Divide by 5. And here we get x equals negative 3 over 5. We divide that out. That gives us negative 0.6. And that's going to be our other x-intercept. So that one on the left-hand side here, pretty much the same steps, but for that one, a is equal to 1. So you just go straight to doing your diamond. And to simplify for it, to find the x-intercepts. Okay, going down towards the quadratic formula. That one I'm going to go ahead and write out. And then use that to find the x-intercepts. Remember that we want to make sure that we have the quadratic formula on our note cards. So I'm just going to do the first one here. So first thing I'm going to do, I'm going to label my A, B, and C. So A equals 4. B also equals 4. And my C equals 1. Okay, so using this, I'm going to plug this information straight into the quadratic formula. So I have negative times B, which is 4, plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 4, times c, which is 1, and then all divided by 2 times a, and that's 2 times 4. So what I'm going to do now is I'm going to go ahead and simplify all this, and hopefully I can fit this all in here. So this is going to simplify to negative 4 plus or minus square root. So right now I'm looking at the discriminant here. 4 squared is 16 minus 4 times 4 is, so negative 4 times 4 is a negative 16 times 1. So that's going to be minus 16. All divided by 2 times 4 is 8. So now I'm looking at the discriminant. 16 minus 16 is going to be 0. And remember the discriminant, when it's a negative number, you have no solutions. So this is just a side note. You have a 0, you have one solution. And then if you have a positive number, you have two solutions. And here our discriminant is going to be 0, so we're only going to have one x-intercept here. So simplifying that out, square root of 0 is just 0, so this is going to be negative 4 divided by 8. And then our final answer, if you put that in the calculator, it'll be negative 0.5. So our x-intercept is a negative 0.5. And this is the one we should box, not this one. That was an accident. Okay, I'm going to go ahead and solve one more of these. I'm going to erase this. And if you need this, you're welcome to pause the video. Let's see, I'm going to do this bottom right one here. So first thing I'm going to do, label my A, B, C. My A is 3, my B is negative 2, and my C is negative 2. And I'm going to plug this straight into the quadratic formula. So I have negative B, my B is negative 2. So negative times negative 2 plus or minus B squared, which is negative 2 squared, minus 4 times A times C, all divided by 2A. And again, so a bunch of simplification that's going to be going on. So this one here, negative times negative 2, gives me a positive 2. So positive 2 plus or minus negative 2 squared, that gives me a 4, so square root of 4. And then here, negative 4 times 3 is negative 12. Negative 12 times a negative 2. Negative 12 times a negative 2 is a positive 24, so plus 24. And then divided by 2 times 3 is 6. Okay, so now we look at the discriminant. 4 plus 24. So this simplifies to 2 plus or minus square root of 28 over 6. So then remember, you have to split these. So what I'm going to go ahead and do is I'm going to go over to the next page. No, I can't go to the next page. Okay, I'm going to erase this here and continue working on it, so it's a little backwards. So it's going to be 2 plus or minus square root of 28 divided by 6. So remember that this needs to get split into two different, so one plus and one minus, two different little equations here. So this is going to be 2 plus square root of 28 divided by 6, and 2 minus square root of 28 divided by 6. Right, and remember, if your discriminant is a positive number, you know you have two solutions. So we have to have two solutions here. Here's one of them. Here's the other one. So if you plug these out into your calculator, I'm going to need a calculator to solve these. So it's best to do 2 plus square root of 28 first. Hit enter and then divide whatever number you get by 6. So I'm going to go ahead and put this in my calculator. And then that's going to give me my first x-intercept of 1.215. So that's my first x-intercept here. I'm going to put this into the calculator this time, and we'll get x equals negative 0.55. And I think it asked us to round to the hundredths, so tenths, hundredths, 2 places. The rest of them, I'm going to just go ahead and put up the answers to them and hope that you guys get them correct. So the other 2 up there. And it'll be just a quick flash, so remember, you're welcome to pause. All right, the application-based test for the factoring quiz. And this is still page 2. So it says the function below maps the path of a bird that dove underwater. So imagine if the bird's coming from here. That's the water right here. So it enters the water here, comes back, and then surfaces back up on the water right there. So it says x is the horizontal distance in feet. F of x, or y, is the vertical distance in feet. The x-axis represents the water level. That said, give the x-intercepts of the picture shown below, then use your calculator to reveal the approximate points in which the bird entered and exited the water. So again, decimal to the nearest hundredth and label them accordingly. So remember, to find x-intercepts, we have to factor. And we can use any of the methods that we've learned, as long as they apply. So if we do something like if we see that a is 1 here, then we can go straight to doing our little x. So it multiplies up to 2 and adds to negative 5. So there's no 2 numbers that multiplies up to 2 and adds to negative 5. Because the only things that multiply up to 2 is 2 times 1. So we can't use that form of factoring. We can't use the diamond method. So for this one, we can't use difference of squares. We can't use perfect square trinomial. So we have to use the quadratic formula. And just to get some more additional practice, we have A, we have B, and we have C. Right? Our A here is 1. B is negative 5, and C is 2. So we can use our quadratic formula, and we're going to plug this in. So negative B is negative 5. So we have the negative from the formula, negative 5, plus or minus square root B squared, negative 5 squared, minus 4 times A times C, all divided by 2 times A, which is 2 times 1, which would just end up being 2. So we simplify this out. Negative times negative 5 gives me a positive 5, where we got a double negative there. Then we have plus or minus negative 5 squared. That's negative 5 times negative 5, that's 25. And then negative 4 times 1 is negative 4. Negative 4 times 2 is negative 8. So that's going to be minus 8. All divided by 2 times 1, which is 2. So the discriminant, I'm going to simplify. 25 minus 8. So 5 plus or minus square root of 17 divided by 2. And remember that because the discriminant is positive, we have 2 solutions here. So we're going to have one that is 5 plus the square root of 17 divided by 2, and one that is 5 minus the square root of 17 divided by 2. Okay, so this is where it mentioned that we need our calculators to go ahead and solve this, because square root of 17 is fairly difficult to do in your head. So plug those both in your calculators, simplify them, and you have your 2 x-intercepts. Okay, so the first one, 5 plus the square root of 17 divided by 2, rounded to the nearest hundredth, is going to give us 4.56. So that's going to be one of our x-intercepts. And our other one here is 5 minus the square root of 17. So 5 minus square root of 17 equals divided by 2. That gives me 0.438, and I'm going to round that to 0.44. So now I have my two x-intercepts, so now I need to go ahead and transfer these onto the graph. So 0.44 and 4.56, you kind of have to figure out which one of these numbers are going to be bigger, right? Because this one here is going to be the smaller number. This one here is going to be the bigger number, right? Because you're going to the right, your numbers are getting bigger. So 0.44 is my smaller one. I'm going to put 0.44, and it's an x-intercept, so your y is 0. So that's going to be that coordinate there. And then 4.56, comma 0 as your x-intercept there. And that'll be your final answer.